To craft our movie recommendation system, obviously, we need some solid movie data. There is actually a dataset which seems to fit perfectly for our needs. You can find it on Kaggle. It has 30,000 movie titles together with the movie plots and some other information that we are going to use. By the way, all the links that I am using with all the important notes you can find in the accompanying article that has everything in one place. Link to this article is in the description box below, or the link will be also on the top of the video. Also, if you are eager to jump into the working code immediately and skip all the explanations which I so carefully prepared for you, that's fine too. You can clone the GitHub repository and get the working project. But I still hope that you will stay here. Now, back to the data. This movie dataset is in a CSV format. However, we'll be mainly working with JSON. That's why for convenience you can either convert the downloaded CSV file into JSON using any of the online tools available, or just use the JSON file that I already converted for you. Again, the link you can find in the article. Once you have the JSON file, put it into the project folder like this. As you can see, my project folder is still empty, apart from the dataset. Now for our movie recommendation system, we want to use vector search. For this, we want to represent every movie description as a vector, a numeric representation of a given chunk of text. Additionally, we also need to transform the search phrase also into a vector. And once we've done that, we'll be in a whole new territory, a multi-dimensional space where our vectors replace the text values. And with some mathematical magic, we'll be able to figure out which movie vectors are closest to the vectors representing our search phrase. By the way, these vectors we call embeddings. Let's see how we can generate them. To create these embeddings, we'll need a model. A model that was trained on millions of examples to spot patterns and be able to convert text phrases into the vectors. And this is where TensorFlow steps in. TensorFlow has libraries that will allow us to run the model locally on our machine and encode text into the vectors. We'll use universal-sentence-encoder. You can also read more about it in the GitHub repository. And to work with TensorFlow and Node, you'll need to install a couple of libraries. And let me copy those so that I don't make some embarrassing typos. The first one is universal-sentence-encoder, which we need to install. And the second one is the backend for it, TFJS Node. You can also notice in the documentation for universal sentence encoders that actually you can also use TFJS without Node, but since we are relying on Node.js and the Node one makes it significantly faster, so we are going to use that one. And I would also recommend that you install first the universal sentence encoder and then the TFJS node, because if you do it vice versa, then you will have to deal with some annoying dependency conflicts, internal dependencies for those libraries. So now that we have two of the libraries installed for the TensorFlow, let's add a file, a JavaScript file, we'll call it encoder. and we are going to add functionality there, which will use TensorFlow and convert our movie plots into the embeddings. And let's actually start with just a single movie for that. But first, of course, we need to include the dependencies for the libraries which we have installed. Again, I'm going to copy this. Here you can see that we are including TF.js node. We don't truly need the output object from that library. However, you must include it because otherwise TensorFlow will loudly complain that the backend is missing. Second one, we are using universal-sentence-encoder, and also we are including the file with the movie plots, which you should have downloaded before. And with that, we can now use the model. So we need to load the model first. And here, to simplify things, I will rely on the then clause so that we don't really need to include any module or any external function to cover it all. So to keep it more simple. But with this, we can load the model, and once it is loaded, we can perform operations with the model. And we are going to convert a single movie plot into the vector embeddings. For this, let's actually catch our sample movie plot. That will be the first one out of our collection. And let's also console log it so that we can... Now, to get the embeddings, we are going to call model embed and give it our sample movie plot, and in particular we will give it the plot itself because we do have some extra information such as the title of the movie, the wiki page of the movie, the director and the rest. We would like just to convert the plot text, the description of the plot, into the vectors. So we are going to do exactly that. And we can output the result via console log. We would need to do extra operation. We would need to call array sync method on the embeddings to get the array with the vector embeddings with the encoded numbers for our text values. And that's actually it. So now what we can do, we can run this code and see if it actually worked. Cross your fingers. So first the TensorFlow platform gets initiated, gives some extra information, and we did indeed got some embeddings there. We can scroll up and see that we do have information about the movie, and this is the plot which we are converting into the numbers. And we have plenty of those vectors according to the TensorFlow model. Great, we transformed a single movie plot into an embedding. Now it is time to set up our Postgres database to store all of our movies and their embeddings and use pg vector. See you in the next video.